Hello learners, and welcome to today's lesson of numeric patterns. Let's start off our lesson with a did you know? So, did you know that number patterns are used in real life? Yes, even the concept of time is a pattern itself. The time allocation for your school periods, the number of minutes in an hour, all these use patterns to function. Let's learn more in our lesson. So by the end of this lesson, you should be able to investigate and extend numeric patterns, write rules in words to describe relationships between numbers, represent numeric patterns in tables, work with numeric patterns that have a constant difference, a constant ratio, and neither a constant difference nor a constant ratio. So that's what we are going to be looking for in our lesson or learning about in this lesson today. Let's move on to the concept map for our lesson today. Of course, the main topic is numeric patterns, and then we are first going to look at representation of numeric patterns, where we are going to focus on representing these numeric patterns in tables and algebraically. Then we are going to move on to solving problems, where we are going to solve for complex problems involving numeric patterns. Let's see what you need to know for this lesson. So you must be able to investigate patterns within numeric values. You must be able to also describe the numeric patterns in words. Let's start off with some practice for this knowledge that we are supposed to know already. Given the following number pattern, so we are given a 4, a 10, and a 16, and of course the pattern does continue. The first question there says, determine the next 3 terms of this pattern. So before we can determine this next 3 terms, we must identify what the pattern actually is. So we can see there that we have a 4 for the first number, then we have a 10 for the second number, and then we have a 16 for the third number. Can you identify how we move from the first number to the second number? Of course, you can see there that we have added a 6. And then what about moving from the second number to the third number? Again, we have added a 6. Yes, you are absolutely correct. So how do you think we are going to find the next 3 terms? Yes, we are going to, from 16, add a 6. And of course, that is going to give us 22. And then from the 22, we are going to add a 6 again. Remember, we are adding a 6 because we have noticed that this is the pattern with those first 3 numbers. So from 22, when we add 6 again, this is going to give us a 28. And lastly, because we were asked for the next 3 terms, so we are going to add 6 again from 28, and that is going to give us a 34. So what are those next 3 terms? We have 22, 28, and of course 34. And that pattern would definitely continue, but at this moment we have only been asked for the next 3 terms. The next question there says, explain in words how you identified the 3 terms in a question. So now that we've identified this pattern, we are required to write it in words. How did we find these next 3 terms? Do you know how? Yes, we add 6 to the previous number. Or we can say the previous term, but we are going to learn more about terms in this lesson. But yes, in words, we add 6 to the previous number. All right, let's look at our next question. So our next question there, we have been given the following number pattern. It is an 8, a 5, and a 2. Can you recognize the pattern so that we can answer that first question that asks us, write down the next 3 terms? What do you think the pattern is there? Well, from 8 to 5, we can see there that we are subtracting a 3. So we are no longer adding, now we are subtracting. So from 8 to 5, we are subtracting 3, What about from 5 to 2? Yes, again, we are subtracting 3. So how are we going to find those next 3 terms? Yes, we are going to subtract 3 to get to the next one. So from 2, we are going to subtract 3. And where does that place us? We are now in our negative numbers and we are at a -1. Now from the -1, again, we are going to subtract 3. And what value do we get there? Yes, we get a -4. And again, we are going to subtract 3 because we are looking for the next 3 terms. So from -4, we are going to subtract 3 again, and that is going to place us at a -7. So what are the next 3 terms there? That is the -1 and the -4 and -7. We are going to stop there, but of course, this pattern continues. Let's look at the next question there. It says, explain in words how you identified the next 3 terms. And as we've already discussed it, we are subtracting 3. So for us to find the next term, we subtract 3 from the previous number. So we subtract 3 from the previous number. Let's continue with another pre-knowledge question. So now we are given the pattern 2, 4, 8, and 16. Can you identify what is happening in this pattern? Well, from 2 to 4, we can see that, yes, we are multiplying by 2. Now, you could easily say that we are adding 2, but then remember, the pattern needs to be the same, even moving on to the next term. So we are multiplying by 2 because, as we can see, moving from the second number to the third number, again, we are multiplying by 2. And again, from the third number to the fourth number, we are multiplying by 2. So that is our pattern there. Now, how can we find those next 2 terms? Of course, we are just going to continue with this pattern. So we are looking for the next 2 terms. So from 16, when we multiply by 2, that is going to give us a 32. And again, from 32, when we multiply by 2, we are going to be given a 64. So what are the next 2 terms? That is our 32 and our 64. Of course, this pattern can continue. Now, how do we explain this pattern, or how we identified the next 2 terms? We can see that here we multiply the next term, or the previous number by 2. So we multiply the previous number by 2, as we have seen there. So that was a bit of a pre-knowledge question, just so that we can remind ourselves of patterns. Let's look at the keywords that we are going to be using during this lesson. So we have there a numeric pattern or sequence, and those are numbers where a common connection lies amongst the numbers to form a pattern. For example, 1, 4, 7, 10, 13, 16, and 19, they form a numeric pattern because they have a common connection there. Then we have a constant difference, which is represented by the letter D. And this is a value obtained by subtracting the first term from the second term and the second term from the third term. So this is represented by D, which is the constant difference, saying there that the second term minus the first term is also equals to the third term minus the second term. So for example, there in the sequence 2, 6, and 10, the constant difference is going to be 4, which is obtained using that formula above there, and that is calculated by saying 6 minus 2, which is going to give us a 4, or we can say 10 minus 6, which again gives us a 4. Then we have a constant ratio, and that is a value obtained by dividing the second term by the first term and the third term by the second term. That is represented by an R as shown there. And of course, we can just say there that R is equals to the second term divided by the first term, and which is also equal to the third term divided by the second term. For example, in the sequence 2, 8 and 32, the constant ratio there is 4 and is obtained by calculating 8 divided by 2, which is 4, or 32 divided by 8, which is also 4. Then we have a term number, and that is the position of a term diagram or a figure in a geometric or numeric pattern. For example, in the sequence 1, 4, 7, the third term there is the 7 because the 7 is in the third position. Then we have consecutive terms, which is terms that follow each other numerically. For example, in the sequence 1, 4, and 7, 4 and 7 are consecutive because they are terms that follow each other. And then we have a rule, which is more of a formula. So Tn is equals to 2n is a rule for a pattern. It is a formula or an equation, not an expression. For example, in the sequence 2, 4, 6, the rule is to multiply the term number by 2. So that is our rule there. Let's quickly go to an ad break, and then we'll see you just now for the rest of our lesson.